Welcome back to another video on the binomial expansion. This is the second video of the binomial expansion, and your presenter today is myself, Aaron Lewis. So a quick topic outline for us. So in this binomial expansion series, in the first lesson, the previous video, we were using combinations and factorials. In this video today, we are applying the binomial expansion to some basic questions. In lesson 3, we are applying the binomial expansion to some more difficult questions. In lesson 4, we are calculating coefficients and indices. And in lesson 5, we are applying the binomial expansion. So in this lesson, we are looking at applying the binomial expansion, or sometimes called the binomial theorem, to some basic questions. This lesson relies on the knowledge already accumulated in the first video. In this lesson, we're going to learn how to apply the binomial theorem or the binomial expansion. This will include using your calculator to work out combination and coefficients. This lesson is suitable for A-level students, and the language of this lesson is English. And the recorded duration of this lesson should be around 30 minutes. The learned aims of this lesson is to be able to apply the binomial theorem, to be able to calculate the coefficient of a given term, and to be able to find the term of a binomial expansion. So first of all, this is what you are given in the exam to support you. So you'll notice we've got a plus b, which is a binomial, raised to the power of n. Now n, over on the right here, is defined as n belongs to the set of natural numbers. Really, that just means 1, 2, 3, 4, and the other positive whole numbers from there. So we're looking for two things in a bracket, two terms, raised to a whole number power greater than 0. Okay, and this formula is what you're given in the exam. So this can look quite scary at first, but we're going to work through it together. You'll notice here that's not a vector, that's the choose button which we looked at in the previous video. So what I'm going to do first is I'm going to do one for you. You don't need to write it down, and we're just going to spot patterns. So inside my bracket, I'm going to have x plus y to the power of 4. So my a is x, my b is y, and my n is 4. So the first term, it says raise a to the power of n. Raise a to the power of n. Next, it says n choose 1. Now n is 4, so that's 4 choose 1. And then it says raise a to the n minus 1. Well, if n is 4, n minus 1 is 3. So that's x cubed. And then we've got b, or you might say that's b to the power of 1, which is y. The next term is n choose 2, which is 4 choose 2. And this time it says a to the n minus 2. Well, if n is 4, 2 take away 2 is 2. Sorry, 4 take away 2 is 2. And then it says b squared. The next term, now it's not on here now, but we can see the pattern. The next one's going to be 4 choose 3 this time. X to the power of 1, or just x. And then y gets raised to the power of 3. Hopefully you're beginning to see a pattern now. And in the last term, you might be thinking, well, it's going to be 4 choose 4. 4 choose 4 is 1 anyway. And if we look at the end here, it says raise b to the power of n, which is going to be y to the power of 4. At this point here, I'm going to work out what all these coefficients are, the number in front of the terms. So x to the power of 4. 4 choose 1 is 4. X cubed y. 4 choose 2 is 6. X squared y squared. 4 choose 3 is 4. X, y cubed plus y to the power of 4. And there we go. There is a binomial expansion for you. What I'd like to do now is just pause the video, and you can either think about this or write this down, and just what patterns do you spot? So what patterns have we found? Now the coefficients are quite hard to spot a pattern with. You might have seen a pattern at this stage here with coefficients. That n is always at the top, and then it goes up 1, 2, 3, etc. What about the powers? Well, we started with power 4, then went down to power 3, power 2, power 1, drawing the little 1 there, and here we could have written x to the power of 0, but that's just 1 anyway, so it's a bit inefficient to write that. What else did you notice? Did you notice that this is y to the power of 1? And we could have had a y to the power of 0 here, but again, that's inefficient. And then this goes to y squared, y cubed, y to the 4. So I've got a nice little pattern going on. As one of the powers goes up, the other one comes down, or as one of them goes down, the other one comes up. What other patterns have we got? Did you also notice that if you add the powers together, it makes 4? And these sort of skills are going to be really, really useful when we're doing questions. So the powers add up to 4. Is there anything else you spotted? Now, not many students spot this one. And this is it's really good if you do spot it. I'm just going to change to blue there. The other thing to notice is this bottom bit of the choose is also the power on the second term. That's 4 choose 2, and that's y squared. That's choose 3, y cubed. If you spot that, well done. If you didn't, don't worry about it. And you would have seen it anyway on the formula up there. So lots and lots and lots of patterns going on. Okay, so you don't need to write that down. I'm just showing you for observations. The next slide, we're going to do one. Okay, so here we go. I've written the formula at the top. I'm going to do the one on the left. You guys can have a go at the one on the right. There is a paper-based resource for this as well, where the questions are already on there for you. So here we go. So I'm going to try and expand 1 plus x to the power of 3. Now at GCSE, you might have written that as 3 brackets, multiply 2 of them, then multiply by the final bracket. But we're going to use binomial expansion because it works for any whole number power, which is greater than 0. Okay, so I'm going to write mine vertically because of space. You might want to write yours horizontally. Okay, so the first term, it says raise 1 to the power of 3. Okay? Now, I overuse brackets, and the reason I overuse brackets is I can put it in my calculator, and I don't need to worry in case I've got any negatives. And then the next term, it says n choose 1, which is 3 choose 1, 1 squared, and then we introduce the x term there. The next term after this is going to be 3 choose 2. It's going to be 1 to the power of 1, which is just 1. And the x term is going to then be squared. And then the last term, instead of writing 3 choose 3, we're just going to write x cubed like that. So let's work them out. Okay, so 1 cubed is 1. And here's the next term. I've just shown this on the calculator. So this is the way I've typed it on my calculator. I've written in 3 choose 1, which is here, which is 3. And then I've taken that 3 and multiplied it by 1 squared, and then multiplied it by 1 because that's the number in front of x. X is also known as 1x. So that comes out as 3x. I'm just going to erase those bits there. So I would be getting really, really comfortable with my calculator. The next term, in my calculator, 3 choose 2, which is 3. Multiplied by 1, then multiplied by 1 squared like that. And all we're doing here is calculating coefficients. This is just going to tell us the number in front. So that comes out as 3. Then x squared is x squared. And on this next term here, x cubed is just x cubed. So my final answer is 1 plus 3x plus 3x squared plus x cubed. Now if you do have a graphical calculator, or in fact a GC calculator will work for this, you can just type in exactly what I've got here. So all I'm doing in my calculator is using that to calculate the coefficient, the number in front of x, or x squared, or x cubed. So I put the choose part in, I put the next term in, which was 1, and then here there's an imaginary 1 in front of the x squared, so in front of the x, and 1 squared is 1, and then I could just use loads of indices. Here's your question to have a go at. Expand 1 plus x to the power of 4. Pause the video and have a go now. Okay then, let's review and see how we got on. Now if you didn't get the answer right, don't worry about it. This might have been the very first binomial expansion you've ever done. And here's the answer. So check that, mark that, improve that, and I'll see you in the next slide. And here's the next slide. So this time, I've changed it a little bit. This time I've got a 2, and I've got a minus x, and I'm raised to the power of 5. So this is a more difficult example. But I'm not going to change what to do. First thing is to raise 2. I'm going to use a bracket, the power of 5. Next thing I'm going to do is going to be 5, choose 1, 2 to the power of 4, multiplied by minus x. So that's where you need to be careful. Because this is a plus in the formula, I have a minus here, it needs to be minus x. The next term is going to be 5, choose 2. You've guessed it, 2 cubed, and then minus x squared. The next term, 5 choose 3, 2 squared, minus x cubed. The next term, 5 choose 4, 2, or 2 to the power of 1, and then we're going minus x to the power of 4. And the final term is always going to be b to the n, looking at the formula. So minus x to the power of 5. So we're going to try and calculate each one of these. Now I'll be using my calculator to calculate these. That's going to stop any small mistakes creeping into my work. Okay, so the first term, and that's what I've typed in my calculator. 2 bracket, and then raised to the power of 5. Now I always overuse brackets in case I need to change the number. If I needed to raise minus 2 to the power of 5, I can just go back and put a minus sign in, which comes out as 32. So this next term here, what's going to go in my calculator is 5 choose 1, multiplied by 2 to the 4, multiplied by minus 1, because that is effectively minus 1 lot of x. And there it is. 5 choose 1, which is 5, multiplied by 2 to the power of 4, multiplied by minus 1 to the power of 1, which is this little bit here. Okay, so that comes out as minus 80, and it's going to have an x on it, like that. The next term is going to be 5 choose 2, multiplied by 2 to the power of 3, multiplied by minus 1 squared, because it's a minus 1 lot of x. So we know it's going to be an x squared term. It's just the number in front, the coefficient. So here we go. 5 choose 2, which is 10. And then I've done 10 multiplied by 2 cubed, multiplied by minus 1 squared. And this is where using the calculator really comes into its own, because we're going to stop any arithmetic errors creeping into our work. And that comes out as positive 80. There it is. I'm just going to erase a couple of bits there. Okay, so the next term is going to be 5 choose 3, multiplied by 2 squared, multiplied by minus 1 cubed. There it is. So 5 choose 3, which comes out as 10 again. And then I'm doing 10 multiplied by 2 squared, multiplied by minus 1, because it's minus 1 lot of x cubed, and make sure you use a bracket. That comes out as minus 40 x cubed. And the last term, let's have a look, or the second to last term, sorry. In my calculator, it's going to go 5 choose 4, multiplied by 2, or 2 to the power of 1, multiplied by minus 1 to the power of 4. And there we go. 5 choose 4 is 5. And then it's 5 multiplied by 2 to the power of 1, multiplied by minus 1 to the power of 4. So if I use my calculator, I'm guaranteeing a right answer. And then this last bit here, I've typed in my calculator minus 1, the number in front of x, the coefficient in front of x, raised to the power of 5. Now you might know that if you raise a negative to an odd power, you get a negative anyway. So that comes out as minus 1 lot of x to the power of 5. And look at that pattern. So my final answer is going to be 32 minus 80x plus 80x squared minus 40x cubed plus 10x to the power of 4 minus x to the power of 5. Okay, here's yours to have a go at. Pause the video and have a go now. Okay, so hopefully you've had a go. Hopefully you've used your calculator like I did and not let any errors creep into your work. And that is the correct answer for that one. So mark it, review it, make edits, redo it if you need to. Next question. So this one, what I decided to do, it's like the previous example, but this time, instead of using a number and a letter, I've chosen 2 letters. Now this one is slightly easier to do. I'm just showing you that you can do it with other letters, doesn't necessarily need to be numbers and letters. So here we go. The first term is x to the power of 5. The next term is 5 choose 1, x to the power of 4, and I can bring in y. The next one is going to be 5 choose 2, x to the power of 3, y squared. So those checks that we looked at earlier, if we remember that if we keep adding the powers up, they should make the power on the bracket there. The next term, 5 choose 3, x squared, y cubed. So I'm probably not going to need my calculator too much for this question because it's 1 lot of x and 1 lot of y. If you have one of these questions to do, you're very lucky. So the power of x is going down. There we go. And the last term then is always going to be y to the 5. So x to the power of 5 is just x to the power of 5. And in my calculator here, 5 choose 1 is 5. X to the power of 4. Y or y to the power of 1. 5 choose 2 is 10. 5 choose 3 is also 10. And that should be a squared there. There we go, that's a cubed. And here, 5x y to the power of 4. And finally, y to the power of 5. So my final answer, I'm just going to write it horizontally. You can write these horizontal if you want to. You might find it easier to go downwards. To go vertically, it might be easier to spot the patterns. There's no strict rules around it. Just tend to do maths in a way which makes you feel comfortable. Try not to make a mistake this time. There we go. And I'm probably just going to run out of space. Saved by no coefficient on the y squared there. Okay. So remember, that is a coefficient, the number in front of the term. Right, here's yours to have a go at. Pause the video and have a go now. Okay, so hopefully you've had a go at this question. And there's your answer. Mark it, review it, correct it if need be. Okay, so this time, I made the question a bit more difficult. So I'm going to have to really, really focus now and use my calculator even more, because this time we've got a multiple of x here, and this number here is greater than 1. But I'm not going to change what I do. First step, I'm going to open a bracket this time. You don't need to. It's going to be 4 to the power of 4. That's a to the n. Next term, 4 choose 1. 4 cubed. You should have gained enough experience now to see what I'm doing here. Now here, this is where I need to be careful. That needs to be a 3x, or 3x to the 1. My next term, 4 choose 2. 4 squared. And please, please use a bracket for that next term there. It's all of, it says b raised to the power of 2. In this case, b is 3x, so you need to take both in there. 4 choose 3. 4 or 4 to the power of 1 multiplied by 3x cubed. Now I'm on the last term now, and that's going to be 3x all raised to the power of 4. Now if you can get to that point, you should be fairly okay, because after this I'm using my calculator. So the first thing that's going to go in my calculator is 4 to the power of 4. Let's have a look, which is 256. What's going to go in my calculator next? Well, it's going to be 4 choose 1 multiplied by 4 cubed multiplied by the number in front of x. So this time it's going to be multiplied by 3. And there you go. So that's 4 choose 1, which is 4, multiplied by 4 cubed, multiplied by 3. So that comes out as 768. And I then need an x on it, because there's an x term there. The next term is going to be 4 choose 2, multiplied by 4 squared, multiplied, now this is basically 3x times 3x. Or you could take the squared inside. Either way, I'm going to be writing 4 choose 2, multiplied by 4 squared, multiplied by 3 squared. So it looks something like that. 4 choose 2 is 6. 6 times 4 squared, multiplied by 3 squared, which is 864 x squared. All I'm doing is letting the calculator square or cube that term there. So the next term, you've guessed what's going in the calculator. 4 choose 3, multiplied by 4, multiplied by 3 cubed. So we know this is going to be an x cubed term. And here we go. 4 choose 3 is 4. So that's 4 multiplied by 4 to the power of 1, or just 4, multiplied by 3 cubed. 432. Now without a calculator, this can be quite long, and you're going to be testing more on your arithmetic rather than your skill of using the binomial expansion. And the last term then, this is going to be 3 raised to the power of 4. We just need to put the x to the power of 4 in there, which is 81. So my final answer is going to be 256 plus 768x plus 864x squared plus 432x cubed plus 81 x to the power of 4. And hopefully you think that's easier than writing out 4 of those brackets and trying to multiply it out. Here's your question. Pause the video and have a go now. Okay, so for this problem, did you notice the sneaky minus sign there? Because if you didn't, you might have got it wrong. If you followed my advice of using the calculator, it should have absorbed all the minuses for you. And there is the correct answer for you. Okay, what I'd like to do now is have a go at mini quiz 1 and get some feedback on how well you learnt the previous section. Unpause the video when you're ready to learn more. Okay, so we've had a practice of using the binomial expansion. And you'll be glad to know that in these next few questions, it's a little bit easier and we're just going to spot things. Okay, so in this question here, we're just after the x cubed coefficient. Now, the second term here is x. So I'm going to recycle some information we looked at earlier. We know the first term would be 2 to the power of 10, and then the next term would be then 10 choose 1. So let me just write that second term down. The second term would be 10 choose 1, 2 to the 9, multiplied by x to the 1. And what I asked you to spot earlier was to notice that that 1 there is the same as that 1 there, and it has to be the second term in the bracket. Well, how's that going to help? Just watch what I do here. I'm after x cubed, and it's the second term in the bracket. We know, therefore, then that's going to be 2 raised to the power of 7, because the powers have to add up to 10. And I'm going to be doing 10 choose 3, because that 3 matches that cube there. So all I need to do now in my calculator is do 10 choose 3, multiplied by 2 to the 7, multiplied by effectively 1 cubed. And there it is. A massive 15,360. And I'm just going to stop there because it asks for the coefficient, it doesn't ask for the term. And there you go. The key thing here to spot is that if this is the second term here, and then you raise it to that power, so it's the right hand bit, if you call that like the left and the right, that becomes the bottom part of the choose. Pause the video and have a go at this next question. Okay, so let's review this question then. So I was looking for x to the power of 5. And it's the second thing again. So that tells me that's going to be 7 choose 5. So if that's a 5, that's got to be a 2. And then putting that through my calculator, we get 21 multiplied by 25 multiplied x to the power of 5, which is 525 x to the power of 5, and therefore 525 is the coefficient. Wonder if you got it. If you didn't, just review that and make a really good note of, if it's the second term, whatever power it's raised to becomes the part you choose. Okay, so next question, we're going to approach this in exactly the same way. So we've got x as the second bit again, and we know we're going to try to get x to the power of 7. So that's going to be 3x to the power of 7. Therefore, that would have been 1 to the power of 6, and it's going to be 13 choose 7. The power on the second term becomes the bottom part of the choose. In my calculator it goes. 13 choose 7 is 1,716. Multiplied by 1 to the 6. Multiplied by 3 raised to the power of 7. Which is 3752892. Which is 3,752,892. And this shows the power of the binomial expansion, because I'm willing to bet a lot of money that you wouldn't want to be raising 1 plus 3x, writing 13 brackets in a row, and trying to solve that. Trying to work that out. So here's your question. Pause the video and have a go now. Okay, let's have a look. What did you get? Did you write 10 choose 7? 1 to the power of 3, and then 5x to the power of 7. And then in the calculator, 10 choose 7 is 120, 1 cubed is 1, And 5 to the power of 7 is 78,125. So the answer, the coefficient of the x to the power of 7 term, is 9,375,000. A massive number. Purely done by the calculator and without having to write the whole thing out. I think that's great. Only a couple more examples left, I think. So this time after the x to the power 4 term in the expansion of 2 minus 5x to the power of 7. Same approach. The x is the second term here. Now just remember it's a minus 5x, so I'm looking for minus 5x raised to the power of 4. So therefore that's going to be 2 cubed, because we know the powers have to add up to 7. And it's going to be 7 choose 4. The second part, that power there becomes that bottom of that choose there. So in my calculator, here we go. 7 choose 4 is 35. 2 cubed is 8. And then minus 5 to the power of 4, I think 625. And it's going to be positive. So here, the power of the calculator, that is sorting out any negatives for me. So the answer becomes 175, 3 noughts, and it asks for the term this time. It doesn't ask for the coefficient, it asks for the term. So in that case, you have to put the bit of algebra on the end. Okay, so here's yours to have a go at. Pause the video and have a go now. Now, did you notice what I did in this one? I was a bit naughty on this one. I just got you guys to think a little bit, because I wanted the y cubed term this time, which meant this had to be to the power 4, which meant this to be to the power 4. So did I catch you out? Did I manage to do it? And there we go. That's the answer for that one. So if I caught you out, make a mental note. Maybe you got a bit of cognitive shock and thought, oh, I thought I got it right, but Aaron caught me out. Okay, last couple of examples then. What is the fourth term of 2 minus 4x to the power of 7 when written in ascending powers of x? So you might notice, depending on where x is written, the x powers might go up or the x powers might go down. Just going to go backwards to a couple of examples. Just go backwards to this one here. Notice on this one, the powers of x go up. So this one is written in ascending powers of x. And the reason that happens is because the x is the second term, because the b's go up by 1, 2, 3. If you move them around, then you get the descending powers of x. So wherever you have the x, depends on whether you get ascending or descending, which we'll have a look at now. Okay, so here we go. So the fourth term, when written in ascending powers of x. Now, it only works in ascending powers of x if the x is the second term, which it is. And I only want the fourth term. So the first term would have been 2 to the power of 7. That'd be your first term. The second term would have had some sort of x in it. The third term would have had some sort of x squared in it. And the fourth term would have some sort of x cubed. So I'm basically looking for the x cubed term. Now it's the second thing. So it's minus 4x raised to the power of 3, just using what I can see there. Therefore, that's going to be 2 raised to the power of 4. And it's going to be 7 choose 3. Again, I'm in my calculator this time. And there we go. So 7 choose 3 is 35. 35 multiplied 2 to the power 4 multiplied by minus 4 all cubed is minus 35,840. And it asks for the fourth term, and I've only written the coefficient. It's going to be x cubed. So that's written in the ascending powers of x. Let me show another example. In fact, you guys can have a go at that one. It's very, very similar to my example. Pause the video and have a go now. Okay, so let's review. How did you get on? It's very much similar to the previous one. Get my words out there. And there we go. Ends up massive. But I'm sure you'd rather do that than write out the full 5 plus 3x to the power of 7, 7 brackets in a row trying to multiply that out. So that focuses on ascending powers of x. What about descending powers of x? So here we go. So if we want to change it to descending powers of x, all we need to do is move the 2x to the front and put the 3 there. Now, if that happens, it means this becomes the a and this becomes the b. And then this gets raised to the power straight away. So we're looking for the fourth term. So the first term, I'm just going to write it here, then I'll have to erase it. The first term would have been minus 2x raised to the power of 12. The second term would have been x to the power of 11. The third term, second term there, and what are we after? We're after the fourth term. The third term would have been x to the power of 10, and that's going to be x to the power of 9. Okay, so this time that's at the front there. So we know it's going to be minus 2x to the power of 9. So therefore, now remember this is on the right, so there's going to be 3 here, and that's going to be raised to the power of 3. And in here, my choose, it's going to be 12, choose 3. I'm going to use my calculator, is going to do all the difficult arithmetic for me. So there we go, 12 choose 3 is 220. In fact, I'm just going to erase some of that, just so you can see my calculator clearly. So 12 choose 3 is 220, and then I have minus 2 to the power of 9, the number in front of x, and then 3 cubed is 27. So that comes out as minus 3041280. So 3 million, etc. 3,041,280. So that's the fourth term. The only thing you haven't done is put a power on it, so it's going to be x to the power of 9. So in descending powers of x, the first one would have been x to the power of 12, etc. So it does matter whether you're doing ascending or descending. You just need to move the terms around. Okay, so here's yours to have a go at. Pause the video and have a go now. Okay, here you go. And there we go. So I've done a bit more work there than you possibly need to. So first thing I do is swap the two terms around because I want descending powers of x. And therefore the third term, 1, 2, 3, 7 choose 2, multiplied by minus 3 to the power of 5, multiplied by 2 squared, minus 20,412. So what I'd like to do now is have a go at mini quiz 2. If you get anything wrong, don't worry about it, just correct it and move forwards. So the learning aims of this video were to be able to apply the binomial theorem, to calculate the coefficient of a given term, and to be able to find a term of a binomial expansion. And that's the end of this lesson. Thank you very much for watching, and good luck with your studies.